it has a sensor component which uses infrared technology to measure differences in light caused by pulses of blood. The hardware aspect of our project consists of the sensor itself, the amplifier, and the filter. And what this does is it allows us to clean up our signal and send it to a device known as a yo-yo, which I have here. I'll be passing it around if you guys want to take a look at it. What this device is, it is Arduino-based technology, which allows us to develop any accessory that we may require and interface it with an Android device. And of course, the other component of our project is the application itself, which records and logs these measurements.
All right, just to give you guys a little bit of a background on why we decided to do this project. Heart rate monitors have been around since the late 1970s, mainly used in medical applications. Since then, the components of electronic devices have been dropping quite dramatically. So they're being frequently implemented for medical as well as personal uses. You see watches that can log your heart rate. Even recently, I've seen apps pop up on the Android App Store where you can try to get the light of your phone to sense your blood pressure and your blood pulses, which is kind of cool. The convenience of having a device connected via Bluetooth to your phone opens up a lot of possibilities to have constant data connection. So the convenience of this is you can have real-time updates, easy access to contacts, and you're able to save data to be able to do it at a different time. As most other devices on the market are standalone with their built-in hardware and software, our project's ability to connect via Bluetooth to an Android device gives it a distinct advantage. So for example, if you want to update and implement new features, if you want to provide the app for different platforms, it's very easy to integrate that. All you have to do is change and update the app.
Okay, I will be discussing the hardware aspect of the project. Okay, as you can see on the screen here, we have the overall schematic design. This outlines every stage from beginning to end. And a special thank you to Professor Chris Rogers for his assistance in the design process. Okay, for the infrared sensor, which is shown here, we chose to use an infrared emitter diode and an infrared detector, which is a phototransistor. And what this does, as I mentioned before, is it measures the differences in infrared light caused by the blood pulses. And these changes are read as an actual voltage across this resistor. So the next stage of our circuit is the instrumentation amplifier. So the primary purpose of this circuit is to remove any high-level noise and amplify a very low voltage signal from the sensor. So when we were designing the circuit, we didn't have any idea of how to determine what resistor values to use. So after a bit of research, we stumbled upon this formula. So we started to play around with it, and we ended up initially starting with the value of resistor values of 100 ohms, which are these values, and a gain resistor, which we had to move of 200. So that resulted in a gain of 2, obviously. And one thing we noticed after weeks of experimentation, we found that the signal was nowhere high enough to be measured. So after substituting different resistor values and simplifying the circuit a little bit, we ended up with what is shown here. Okay, the next stage in our circuit is the filtering circuit. So in order to remove any other residual noise, we chose to use a 4th order Sallen-Key low-pass filter. So when we were designing this part of the circuit, we chose to use a critical frequency of 5 Hz, which in turn results into running at 300 beats per minute, which is pretty high. So if you guys have a hardware that, please see it up. So 2 of the key formulas, I should say, in this design process is the first one here on the, I guess this is the left. This one here, the damping factor formula. So to determine the capacitor and the resistor values here, these 2, we had to use this formula. And in order to get the critical frequency of 5 Hz, we had to use 100 kilo ohm and 1 mega ohm resistor and 100 nanofarad capacitor. Regarding the damping factor, this was adjusted so we can obtain a response, Butterworth response, which is an optimal which is the optimal response required to give us the best signal. And as you see at the end of the circuit here, while it's not part of our actual filter per se, it's more of a precaution. The reason why we had to implement the Zener diode and this resistor is to prevent any unsafe voltages going into the yo-yo itself. The yo-yo has its own limitations. We can only take 3.3 volts max at the pin. So if we send anything higher than that, obviously, we'll. Okay, as you guys have probably seen, between going around, this is the yo-yo itself, as I mentioned already. It's based on Arduino technology. It has its own firmware and its own Android libraries. And as I mentioned as well, it can allow us to interface with the Android device. And the final product, as you can see in this picture here, this was initially our final circuit. However, we ran into a few issues, and today you won't be seeing that, unfortunately. So for today, this will be our demonstration circuit.
All right, now we're going to spend a little bit of time talking about how we implemented the software before we get into the demonstration. So our goals for the software, number one, were to measure the heart rate and display it in real time, both graphically and numerically. So we have a little graph, show the pulses, and then it'll show your beats per minute. To save that file, save that data to a file, which can be emailed to a contact, or you can see it and view it at a different time. And it can detect whether our heart rate is above or below a certain threshold. So depending on your age, depending on what your beats per minute is, it'll actually show you a message and tell you you're at rest, you're within target zone, or you're in danger zone.
Danger zone.
So this is the main activity of the application. It includes a quick view, which allows the user to verify that they have an acceptable reading before actually recording. So the purpose of this was, unfortunately, due to the limitations of some of the hardware that we've implemented, you have to have very specific pressure to get a good reading. If your pressure is not good enough, the voltage will drop below what we can read, and if it's too high, it will go obviously too high. So the reason for implementing a quick view is just to make sure you have a good reading, and then you can get into the next mode. You can choose between a real-time mode, which will monitor, record, and show the beats per minute. You can email to anybody you want, or you can log it. You can view a most recent log, and you can change settings. So now I'm just going to talk about real-time mode. Obviously, once you've gotten a good reading, it'll show you your signal here. After 10 successful cycles are read, the reading will show up here in the middle, and it will tell you, depending on your beats per minute, at rest, or your target zone, or it'll tell you to slow down. Every successful beats per minute reading is written to a file along with the time and date of that reading. So in the next couple of slides, I'm going to be talking about the code that we implemented to be able to actually read it, because obviously what we were getting in is we were getting the voltage level very similar to a sine wave, and we we're having to read the peaks and get the delta t. So this first function is just to show whenever the voltage is 0, it'll just say not connected, obviously. Next one. This is the first peak. When the first peak is read, the voltage and the time of the peak are stored, and the first flag is raised. This is just to say, hey, we found the first peak. Once the first flag has been raised, it'll check for the first value. When the first value is read, same thing. We take the voltage and the time of that, and we raise the second flag. And as you probably guessed, the same method is used to determine the second peak. As soon as the second peak's found, same thing. Voltage and the time are taken in, and the third flag is raised. Once all these three flags are raised, we go into calculating the beats per minute. So obviously you take the difference between the second time and the first time, and then you divide 60 by that. That'll give you a BPM reading. Now what we do here is we actually take this into an array of 10 values, just so you don't see every 50 milliseconds. That's the reading that we have, that's the resolution that we have. So it doesn't show you beats per minute every 50 milliseconds. We took it into an array, and then you'll see on the next slide, we just add all those array values together, divide it by 10, and then you get an average over that period of time. And then we set it up here, and you see BPM reading. This is the next section of software, which is called the email section. So we'll show you here which log is going to be sent. You can click browse. That's my email address. Don't email me anything. You can click browse. You can select an email, or you can actually type something, and you don't have to actually have to click browse. And once you click send, the next slide will be shown. It'll automatically open the Gmail application. Now, you don't have to implement it like this. We decided to implement it this way because we assume that most people using an Android device are going to be using Gmail, but we hard-coded the Gmail app to open. Now, you can hard-code a selection, so it'll say you want to open this app, you want to open this app, but we decided to do it like this a little bit more clean. And as you can see, the subject field, the recipient field, and the body are automatically updated into this app. And then the settings, lastly, you can set an automatic contact, you can set your age, your weight, and the time to send the automatic update. So when you click save, the field will be automatically updated, and that will be sent to a file, and then once you open the application again, that file will open up, and you don't have to enter that every time, obviously. Alright, so now we're going to do a demonstration. You might want to come in a little bit to be able to see the actual phone. So as you see here, nothing's really happening until we turn on the device. Once this turns on, it will automatically start detecting.
Okay, so right now when my hand is off the sensor, you will see no voltage recorded at all. So if I press down on the sensor at full pressure, it'll go to the highest voltage possible. So like as we mentioned before, the issue that we had with the sensor itself is that you actually have to fiddle with it a little bit and figure out the optimal pressure, which can take some time.
Yeah, depending on how coarse your skin is, what color your skin is, it might actually take a little bit to get a decent. I actually tried it with my dad last night, and because his thumb is so calloused, he couldn't get a reading off the thumb. I had to use it on his finger actually.
But pretty critical. You just
Yeah, so you kind of have to play around with it a little bit. It actually, for some reason, it doesn't work as well with Josh as me.
Yeah, let's get somebody else's skin here.
Our own project.
It's a racist project.
So we're able to see, now we can, now that we have a good reading, decent reading, we'll go into real-time mode and we'll see how fast my heart's beating right now. It's going to be pretty fast. 136. So this is within the target zone, it's called, which
For working out?
theoretically I'm exercising right now. And if you pinch it a little bit too quickly, or if, like, obviously I was talking while we were doing it, that's how kind of sensitive it is. Even if you're talking, you can see it's kind of jumping around. So you have to kind of
Silent chain.
and you'll see.
129. Do you have to wait for 10 seconds or 10
Yep.
samples?
10 samples.
Yeah, it's pretty good.
Someone else want to try it?
Yeah. Please.
So you just kind of got to pinch it, and you kind of have to vary.
Push hard on the
But do it till you see the sign right here.
Yeah, so you'll see it.
Yeah,
You'll
it's
kind of
a
want
good
to. You'll kind of want
A
to.
little harder.
So harder?
Yep.
A little harder and a little soft there. A little
See
less.
it?
Just a little less.
And you want to pull off a little bit. Pull off a little bit more. It'll still, as long as it's getting variations, it'll still give you a reading, which might not be correct until you actually get it. Pull off a little bit more. There you go.
Getting there.
There you go.
That looks like a heartbeat.
54 guys?
Perfect.
No, that's what I mean. Me is usually low, so it's correct.
So yeah, so if we go,
Like 50, 55 usually, yeah.
so if we go back, if we go to view recent, you'll see the logs here, 136, 161, and they'll say 2014. This is actually military time, which is pretty cool. Now if you go to email, we can actually see if I can find Professor Rogers here. And it automatically opens up his email address. Now, if you have multiple emails inside one contact, it'll just pull the first email. And if you don't have any emails in that contact, it'll actually tell you, hey, there's no emails. And you can send it. It'll pull up the Gmail here. You can just go ahead and send that send that message.
So you're getting
So he'll get that. So he'll get that log.
It also says, give us an A+. Or
And then obviously on the settings as well, you can type in an email address.
One issue that we had here for the automatic sending is that if once you set a time and the time pops up, for the entire minute it'll keep popping.
Yeah, I had some issues implementing that. So essentially it'll pop up with the email, but I didn't set a flag for it, so it'll just, for the entire minute, it'll just keep on popping up the actual Gmail application. But you can still set all this stuff and save it, and it'll save your information there.
Very impressive.
And yeah, that's pretty much. Oh, and then you're seeing this, seeing the Gmail app pop up, and it'll keep popping out. That's one thing that we didn't really have time to.
You got the email working. Yesterday it was questionable, right?
Yeah, I wasn't sure if I was going to be able to implement it at all, but